What are stars? Stars are massive, luminous spheres of plasma that generate energy through nuclear fusion. Their properties, including size, brightness, and lifespan, vary depending on their mass, temperature, and stage in the stellar life cycle. Stars serve as the fundamental building blocks of galaxies, influencing cosmic evolution through their life cycles and eventual deaths. Things that would like to be stars. To understand stars, we begin with objects that almost made it. Large gas giants and sub-brown dwarfs, like Jupiter, share some star-like qualities. Jupiter, the most massive planet in our solar system, is 11 times Earth's diameter and 317 times its mass. It is mostly composed of hydrogen and helium, similar to the Sun, but lacks the necessary mass to ignite nuclear fusion. Despite its immense size, Jupiter remains a cold, lifeless gas giant rather than a star. Brown dwarfs, the failed stars. Brown dwarfs occupy the transition zone between planets and stars, with masses between 13 and 90 times that of Jupiter. Even if 90 Jupiters merged, it wouldn't be enough to create a true star. Instead, additional mass makes brown dwarfs denser, increasing core pressure enough to cause limited nuclear fusion reactions, making them faintly glow. These objects are sometimes referred to as failed stars because they fall short of the threshold for sustained hydrogen fusion. Main sequence stars, true stars. Once a gas sphere reaches a critical mass, its core ignites, fusing hydrogen into helium and releasing immense energy. These are called main sequence stars. The more massive a star, the hotter and brighter it burns, but also the shorter its lifespan. When the hydrogen burning phase ends, the star expands dramatically, transitioning into giant phases. Types of stars. Red dwarfs, the smallest stars. Red dwarfs, the smallest main sequence stars, are about 100 times Jupiter's mass, barely enough for fusion. They are small, cool, and dim, with lifespans reaching 10 trillion years, far exceeding the universe's current age. Barnard's star, a red dwarf near Earth, is invisible without a telescope due to its faint glow. These stars are the most common in the universe and may outlive all other stellar types due to their slow-burning nature. Sun-like stars, moderate-sized stars. The Sun dominates our solar system, accounting for 99.86% of its total mass. It is 7 times more massive than Barnard's star but shines 300 times brighter. Stars like our Sun burn hotter than red dwarfs, limiting their lifespans to around 10 billion years. As the Sun ages, it will exhaust its hydrogen fuel and expand into a red giant before shedding its outer layers and forming a white dwarf. Massive stars, bright but short-lived. Small increases in mass drastically increase a star's brightness. Sirius, the brightest star in the night sky, has twice the Sun's mass but shines 25 times brighter. Stars nearing 10 times the Sun's mass, like those in Beta Centauri, reach temperatures of 25,000 degrees Celsius and shine 20,000 times brighter than the Sun. However, their lifespans are only about 20 million years, much shorter than smaller stars, as they burn through their fuel at a significantly faster rate. The most massive star, R136A1. R136A1 is the most massive known star, at 315 solar masses and nearly 9 million times the Sun's brightness. Despite this, it is only about 30 times the Sun's size. Its extreme mass causes it to lose 321,000 billion tons of material per second due to stellar winds. Supermassive stars like R136A1 likely form from mergers of several high-mass stars in dense star-forming regions. They burn out in just a few million years, exploding as supernovae and enriching the cosmos with heavier elements. The biggest stars, Giant and hypergiant stars. Red giants, growing through death. When a main sequence star depletes its hydrogen, its core contracts and heats up, triggering more fusion and causing the outer layers to expand. Gaykrux, only 30% more massive than the Sun, has already swollen to 84 times its radius. The Sun, in its red giant phase, will expand to 200 times its current size, engulfing Mercury and Venus, and potentially even Earth. This transformation marks the final evolutionary stages of medium-sized stars. Hypergiants, the true behemoths. Hypergiants are the bloated remnants of the most massive stars, radiating incredible amounts of energy. Their immense size makes them unstable, causing them to eject mass in powerful stellar winds. These stars shine with incredible luminosity and are often visible across vast cosmic distances. Pistol star, a blue hypergiant, 25 solar masses, with a radius 300 times that of the Sun. It is one of the most luminous stars known. Rho Cassiopeiae, a yellow hypergiant, 40 solar masses, with a radius 500 times the Sun's and a brightness 500,000 times greater. Despite its massive size, it is an incredibly rare and short-lived phase in stellar evolution. Red hypergiants, the largest stars known. Red hypergiants are the most massive stars ever observed, though their exact sizes remain uncertain due to their instability and distance. These behemoths continuously shed mass as they reach the final stages of their lives, eventually exploding as supernovae and leaving behind either neutron stars or black holes. The largest known star, Stephenson 2-18. Stephenson 2-18 is estimated to be 2,150 times the Sun's radius, making it one of the largest stars ever discovered. If placed at the Sun's location, it would extend beyond Saturn's orbit. Even at light speed, it would take 8.7 hours to travel around it. A jet flying at maximum speed would take 500 years to circle it. As it evolves, it will shed more mass, collapse into a supernova, and enrich the galaxy with heavy elements, possibly leaving behind a black hole or neutron star. Conclusion: the largest star in the universe remains a changing title as measurements improve. Whether R136A1 holds the record for mass or Stephenson 2-18 for size, these cosmic giants highlight the incredible diversity and scale of the universe's stars. As our technology advances, future discoveries may reveal even larger and more enigmatic stars, continuing to expand our understanding of the cosmos. The 10 biggest stars in the Milky Way. Stars come in a wide variety of sizes. Some are small and some are big. Some are what we would consider to be behemoths. The Sun may seem big to us from our small, rocky world, yet it is dwarfed by some of the other stars in our galaxy. What are the 10 biggest stars in the Milky Way? 10. Antares. Antares is a red supergiant located some 550 light-years away. Estimates place the size of Antares at 832 times larger than the Sun, making it one of the largest stars in the Milky Way. If you were to place Antares where the Sun is in our solar system, it would stretch past the orbit of Mars and perhaps even reach as far as Jupiter. Estimates on brightness vary, but it is at least 70,000 times brighter than the Sun. By mass, Antares is 12 times more massive than the Sun. When Antares eventually dies, it will become a supernova and form either a neutron star or black hole. 9. Betelgeuse. Betelgeuse is one of the most popular stars in the Milky Way. In fact, it is one of the only stars other than our Sun where astronomers have actually photographed the star's surface. Betelgeuse is one of the largest stars in our galaxy with a diameter 887 times larger than the Sun's. Betelgeuse is located about 640 light-years away in the constellation Orion. Betelgeuse is currently in the final stages of its life and will likely explode in a supernova in the next 100,000 years. 8. KW Sagittarii. KW Sagittarii is a large supergiant star located in the constellation Sagittarius some 6,200 light-years away. As one of the largest stars in our galaxy, it has a diameter 1,009 times larger than the Sun. It is 200,000 times brighter than the Sun. 7. VV Cephei. VV Cephei is a red supergiant star located in the constellation Cepheus some 5,000 light-years. VV Cephei is actually part of a binary star system, yet its companion star is far smaller. VV Cephei is around 1,050 times larger than the Sun, yet some estimates place its size even higher. 6. Mu Cephei. Mu Cephei is one of the largest stars visible to the naked eye, being over 1,200 times the size of the Sun. If it were placed in our solar system, it would stretch beyond the orbit of Jupiter. Mu Cephei is nearly 300,000 times brighter than the Sun, making it one of the brightest red supergiant stars in the Milky Way. 5. KY Cygni. KY Cygni is a red supergiant star located in the constellation Cygnus some 5,000 light-years away. KY Cygni is 1,430 times larger than the Sun and 273,000 times as bright. Despite its brightness, it is not visible to the naked eye. Interestingly, KY Cygni is hidden in a dense cloud of hydrogen that blocks most of the light it emits. 4. V354 Cephei. V354 Cephei is a red supergiant star located in the constellation Cepheus some 8,900 light-years away. With a size 1,520 times larger than the Sun, it is among the largest stars in the Milky Way. It is also one of the brightest stars in the galaxy, having a luminosity over 400,000 times that of the Sun. 3. RW Cephei. RW Cephei is a yellow hypergiant star located in the constellation Cepheus some 3,500 light-years away. It has an estimated size 1,530 times larger than the Sun, making it larger than the orbit of Jupiter. 2. VY Canis Majoris. VY Canis Majoris is one of the largest, most massive, and brightest stars ever observed in the universe. With a size larger than 1,500 suns, it has an estimated mass of 60 suns based on a brightness that is 400,000 times brighter than the Sun. VY Canis Majoris is a hypergiant star in the constellation Canis Majoris some 3,900 light-years away. As a hypergiant, VY Canis Majoris is relatively young, having an estimated age of less than 10 million years. 1. UY Scuti. The largest known star in our galaxy, and one of the largest stars ever discovered in the universe, UY Scuti is over 1,700 times larger than the Sun. By volume, you could fit over 5 billion suns inside UY Scuti, which goes to show just how gigantic this star truly is. Despite its immense size, UY Scuti is only 10 times the mass of the Sun and 100,000 times as bright. UY Scuti is currently in the final stages of its life, and it is only as large as it is because the star has expanded as it nears the end of its life. Given its mass, UY Scuti will explode in a supernova, leaving behind either a neutron star or black hole. Like, share and subscribe my channel for your support. More informative videos. Thanks.